Another draft physics video. Yay. So we'll do the motion argument. This, Holiday's being belligerent and obnoxious and making these accusations that somehow I haven't given enough explanation. So a few years ago, I realized that it's much simpler than I was attempting to make it, because I was attempting to use the standard model and recognize everything as hurricanes swirling, or like the big universe, galaxies, and all this round dynamics. And in the small scale, there's not the same kind of pressure. There's not the same kind of influences. The inverse square law isn't really at play. All of this stuff is much more direct and straight line. And the geometry is probably a lot squarer. And so it's just more direct. So I have argued that there's a difference between force and matter. And one of the most obvious differences is forces only move in one dimension. They have a one-dimensionality, like a photon of light. It really doesn't have any substance side to side or this way. It only has substance in the dimension it's moving in, and that's it. And if it doesn't hit anything, it's like it doesn't exist. But anyway, where regular matter exists in 3 dimensions. It has elements moving in all the dimensions. Pieces. And that's the difference between force and matter. Matter's 3-dimensional, has bits moving in all the dimensions, and force doesn't, 1-dimensional. Alright, the major difference. Okay, so the idea of material motion, I've sort of drawn out an electron and pointed out that, so I'll draw it over here just to not use up too much space, that the idea would be is that if the same force comes into it, essentially it just it does a reflection in a way, but it basically creates a little bit of momentum in this direction. But the real tricky part is when something of the opposite polarization comes in. This is what it does, is it interacts with a bit going the other direction, perpendicular, and what happens is the bit that came in goes out perpendicular, and the electron will have a bias in this direction, but because it gave up an element going this way, it'll also have a bias in this direction, so it'll move something between those two. Who knows? It depends on what other previous biases it has, will decide how dramatically it moves or in what direction it moves. But that's why electrons don't move very straight, and that's sort of something that is noticed in physics. Alright, so in an atom, so the point is, and then electrons, when they're moving, when they say they have some of this velocity, they can't really hold it because there's force coming from all sides all the time interacting with it. And what happens is whatever imbalances it has, those imbalances will tend to get worn out. So the argument is if say it has 3 arrows going this way and only 1 arrow going this way, and it's getting bombarded by a random field energy from these both sides, what's going to happen is there obviously, by laws of probability, will be more interactions with stuff going this way than stuff going this way, and it will tend over a certain period of time to convert the ones going the wrong, the imbalance will be, just by the laws of averages, converted back into a balance. And that's so electrons can't hold velocity. That's why you have to keep pushing them. You have to they have to be under acceleration to maintain momentum. And if something's not force, if there's not a force, if you don't have a cathode and an anode that forces the electrons by constantly pushing them. So if the electron is not getting constantly pushed by an electric charge, thousands of volts, hundreds of thousands of volts or whatever it takes to move the electron, a constant flow of force has to push electrons. and that's why they have to be moved in vacuum and all that. So anyway, so let's get to the atom and motion. So I would argue that the simplest way to think of it as a metaphor is this idea of a school of fish, that you have a closed system and it has bits inside of it that are going in all directions. And the idea is you inject force into it, extra force. So it has force coming from all directions, but we have a little bit extra coming from one side more than the other side. And the idea would be is this perpendicular thing will happen, and stuff going this way, you know, perpendicular to this force, will end up getting released, and the stuff inside will now retain these new bits going in this direction, and it'll create an imbalance. And in a material bit, that imbalance is maintained in the sense that there's a system in it of feedback that keeps the energy flowing and then maintains the imbalance. So the imbalance doesn't escape perpendicularly anymore. Well, in this case, the imbalance doesn't get released forward by some perpendicular exchange. So it maintains its velocity. So that's the key difference between an electron and an atom. An atom can maintain its velocity where an electron or a proton can't. They'll run out of steam if you try to shoot one out of a cannon in space or something. It won't just keep going. It needs to be caught up in a system with another electron. The proton needs an electron, or the electron needs a proton, to create a mechanism where it can spiral and eat space, essentially. So I've used the argument that precession is what's sort of the likely cause of motion for atoms. That inside the atom, the force is processing in a circle, and the circle it does more in one direction than it does in the other direction. Therefore, it moves over time in that spiral. All right, now the mechanism that would cause something like that, I'd say, again, to use the fish metaphor, if you think of something as having a bunch of motions, so let's draw these motions. These are motions, directions that stuff can be going. All right, and now I'm going to interact with that with a force. So there's a force that's going to come into this equal system, the system in a neutral state. But let's say it doesn't have to be in a neutral state. I'm just going to change the balance. So let's just say there's a million going this way, and a million going this way, a million this way, a million going that way. Now, something you could obviously see from this perspective is that these arrows use up more space. So you could even just argue from a volume sense, these directions are bigger than these directions. So this arrow would be more likely to hit stuff going this way and that way than it is to hit stuff coming straight at it, or stuff, oh, didn't draw this arrow properly. Yeah, sorry, my mistake. I guess I should have done it in black and blue, maybe. Black and blue, that would be very attractive, maybe. You have these, you know, since I did one, I might as well do the other. So just as a mechanical approximation, just as an analogy, you can think of it this way, that the sides of the square are bigger than this side as a profile. So if I was hitting just a square, you could sort of understand that the odds of an arrow hitting this profile are a lot higher than it hitting these profiles. Only a tiny percentage will hit those profiles. And as I've explained, in this system, when head-on collisions mean nothing in kinetics, it's like the kinetic balls hitting each other, the solution, you know, when they collide, will be identical as if they missed each other. So if I had two kinetic balls and they actually hit each other in the center and then bounce back, it'll look exactly the same as if they just missed each other and just went on about their business. The universe doesn't change at all. And so this interaction is a null. Nothing happens. And this interaction going the same way, well, all these bits are moving the speed of light. So this interaction can't really happen. This arrow can't really hit this arrow because it's already moving the speed of light. So it can never hit one because it can never catch one. It can only slide in between. Say one's going here and one's going here and one's going here. Obviously, as they rotate in a circle, you could fit a new one in here, and you could fit a new one in here and increase the number of them. But you can't really push them. You can't really hit one and change one. So this interaction is a null, and this interaction is a null. And so the only interaction you really have is the perpendicular one, where this force comes in, hits something going perpendicular, in a sense allows that to be released out of the box, and this new piece of force goes into the box. So the box gains an arrow going this way, and it loses an arrow going this way. And so now it has an imbalance. It has more stuff going this way than this way, and so you could sort of see if the box was rotating, having more stuff going one way means the box will tip and it'll rotate. And so as it rotates, it'll move in a direction of that rotation. So that's a simple diagram of it. Now, based on my theory, okay, these arrows can't hit other arrows technically. Okay, they can only hit the bits inside of electrons and protons. So what it's really having to do, this force, is going to really cause electrons to move, or it's going to create more electrons. It's going to add more stuff into this mechanism. So in the real circumstance, let's say these red things are protons, and we'll make the blue ones electrons. And for the sake of argument, I'm not drawing a real atom here, but obviously we know atoms have a geometry. And in substances that are rigid, there's another argument you can sort of understand, that it's kind of easy to push with a force objects that are solid. Okay, solid objects are easy to push. So where the atoms are in strict positions and they don't move about very easily, you know, it's very hard geometry, those objects are easy not to waste any force. Every bit of force you put in kind of goes into the object's movement. But when the atoms aren't very stuck together, when they're loose, you know, and chaotic and have a lot of movement and energy in there, and nothing's really glued to each other very strong, it's just weak bonds, then it's mushy. And when you apply the force, it just mushes. And it's hard to get it going. It's like a sponge. It just, you know, it's hard to get the whole thing to go, and you end up losing a lot of energy in squishiness. So you understand that in this model of where you're giving acceleration to a material body, it's likely the material body has a rigid geometry. Everything's in a rigid position. And so the argument is that as force hits, it's going to hit the electrons going this way, and it's going to hit the protons. And there'll be two kinds of force, a mixture of both forces. So you'll have the stuff that interacts with the blue. I should have drawn it as blue, I suppose. And then you'll have stuff that interacts with red. And the point is the blue stuff is going to release stuff. It's going to convert. The red arrow that comes in is going to be leaving perpendicular. And likewise, the blue that comes into the red will be leaving perpendicular as a force, and these bits themselves will gain momentum in the direction of the force, so they will move their position. And the idea would be is if this proton moves here, that means it's going to be closer to this proton here, and they have a very rigid repulsion to each other, and so that's going to mean that they have more little bits between here are going to get more pressurized. The ones going between these electrons and protons, all this energy is going to get more pressurized by that compression. So all of the repulsive energy is going to become more pressurized. That is, more interactions back and forth, a higher frequency. and the tendency is going to be to push this proton by that extra pressure in the direction that this one moved. So as these little bits move through their repulsive force, they will move each other, and the tendency will be to move in this direction. And the question is how does that get maintained? And I would argue that that's sort of the charge phenomenon. That's what the current inside of everything is sort of made out of, is this idea of likely, as you tend to push everything in a direction, you're getting rid of the sideways motion. So again, the thing excreted is pressure on the outside. So you could argue that when bullets fly through the atmosphere and you take a picture of a bullet, if you can take a high-speed film of a bullet going through air, you will see a bunch of turbulence created around the bullet. And I would argue that the part of the fact of that is actually the force getting released out of the bullet, especially on takeoff. Acceleration is where this all happens fundamentally. And so through acceleration there's a sideways force that's excreted by everything, and that tends to create the environment where there's no friction with the barrel and all that kind of. You can make lots of arguments about the impact of that, but you can sort of see it in things, in motion of things. And clearly the more velocity I give this bullet, I don't really want to get into this force on force thing, but when it interacts with a surface, what's really easy to notice is the bullet falls apart really easy. It's degraded by this velocity, in the sense that it's not gonna hold up as it would as a solid bullet. If I push a bullet against this, against any object, it doesn't go through it. But if it has velocity, it goes through, because it melts. Essentially, the surfaces all degrade and collapse because of all this velocity, all of this change in this atomic structure. So this structure is weakened by the fact that it's doing this motion. So again, the key point would be is that when you're getting rid of the stuff going this way and going this way, you're in a kind of a sense making the object less and less material in that direction, and so you'll have more stuff going the way that this force went in, because it's making clear exchanges. So clearly there's going to be more pressure in one direction than in any other direction, certainly in the opposite direction, because you keep adding pressure going one way to the system, and with each time you do that, these protons move. And the argument is they move in a procession. That is, because you're degrading this motion, the movement of the force around these right turns that are taking place, essentially, right? The blue force just keeps right turning, and the red forces inside keep turning between the electrons. And both of them are holding more pressure. So the atoms themselves might be expanding a little bit, and they're clearly expanding in the length directions and narrowing in the width directions. And my argument is through each one of these motions, it's like a spinning wheel, kind of. So the wheel's spinning. Now if I hit the wheel with a bit of stuff in the direction of its in the right direction, or even in the wrong direction, it doesn't really matter where I hit it. The fact is, I will cause it to process. I just won't make it spin faster. I'll make the wheel process in its motion. And so the same thing is happening in this, is that it's just going to start processing, because everything looks like new motion. Everything looks like an addition. And it's just going to keep thinking every time the motion goes in this direction, it's going to look like there's extra motion. And so it will process through space and that's going to be its velocity. And so, light is 3 million meters per second, and that's the force speed that goes in. And clearly through this process it doesn't take too much change, to think that, okay, this is going to process at 50 miles an hour. Now, even though 50 miles per hour is kind of a fast speed from us, from our perspective, it's clearly so much slower than the actual speed of the force that went in. So that's how diluted and how minor that procession is. That the procession speed is only 50 miles an hour, where all the bits are really moving the speed of light inside the atoms, except the little bits, the force bits that are moving between the particles. The particles aren't moving fast at all. I don't think the particles are moving at all, frankly. I think the protons and electrons, they're not spinning around each other as the standard model has it. They're in rigid magnetic positions. Can't really see that. So I would argue that electrons and protons are in strict geometry, and that atoms are held together by that strict geometry. That everything has to be located in specific positions, so the pressure between any two electrons is always the same distance between all the electrons. Because any change, any more pressure between any two electrons, if I change the pressure, weaken the pressure here and increase the pressure here, the rebound is going to be to force that thing this way, and then force this thing this way, and then force this thing this way. And so it's always going to compensate for those changes in pressure. And so essentially what you're doing when you're shooting force in is you're creating a lot more pressure in this direction in all of these atomic systems. You're just pushing an awful lot more pressure this way into the system. An imbalance. And the imbalance will be converted into the square motion that is the basic function of the atom. So I guess it's hard to make all this stuff perfectly clear, but to understand the atom's common function is the little force bits are moving between the protons, and they're likewise for the electrons, they're bouncing back and forth between electrons. So if there was two electrons here and here, there's force bouncing between them. The protons have force bouncing between them in the form of the red force. And then the blue force is traveling between the protons in patterns that could be circular, because of the fact that it's always a perpendicular exit. And so this geometry is rigid. It's not, it can be bent, it can be made crooked, but the protons aren't moving and the electrons aren't really moving. They're just vibrating. The electrons are in positions, and as the pressure changes, they'll move from this position to this position, and every time they move, they change the balance between each other. And that balance will always have to be regained by an equal and opposite reaction, so to speak. Yeah, so what else to say? So, but I think that's enough of a model to understand what's really just happening is force going this way is just being exchanged for internal force that's going this way or this way. And so you're just changing the balance of the matter and creating more of it that's going this way than it's going this way, or whatever. And it's and that change happens inside a structure that's consistent. So the change is constantly felt because of the force imbalance. The fact that there's more going this way, more pressure, so these protons end up going further apart from each other. And the counter reaction is these go closer to each other, probably, as a counter to this increase in pressure. There has to be more pressure spread in some other place. They have to get rid of the pressure somewhere. So the pressure moves into the other direction, and so these compress and these expand, kind of a thing. So the two sides, essentially, the side going one way outbalances the side going the other way. So you can think of it as just a lopsided circle. And the lopsided circle can't really be lopsided. So instead of being lopsided, it moves in a direction. Alright, I hope that is more of an illustration. But again, as I've pointed out, this then explains how you can store energy inside of an atom by creating more force. And it's perfectly reasonable explanation for a mechanical mechanism and how the force is held by matter. And another way of holding the force would be, see, I got a little bit of room here, would be the idea of, see, I'm talking about adding arrows, but you could also add electrons. So if you put more electrons in the square, you could sort of understand that that would multiply any force that's interacting between them. Where the force used to go this full distance and then back, now the force is doing these much quicker frequencies, so there's a lot more impacts going on, so there's a lot more pressure. So adding electrons increases pressure, and it's the release of the pressure that we call the gain of energy or work. Pressure creates movement. Movement is analogistic to work. Alright. I hope that helped.